Right, okay, so when we're searching, we're going to be looking at storing our data. We can't use single variables to hold our data, so we use a list or an array. Okay? And as soon as we put our data into that list or an array, what we get is the ability to process it. And unless we do this, you can't use these fancy search methods. So we've got it all in a list. So we refer to that list with a name. We'll call this one data. And then each piece of data, each item that's stored, is stored at a consecutive location. Okay? Starting with position 0, 1, 2, and so on. Okay? Whenever we're asked to describe how an algorithm works, what they're saying to you is, how does it start? What's the process that goes on, so the middle bit, and how does it end? Okay, so with the linear search, it starts with the first element, the first item. So whatever we're looking for, so if we were looking for, and I've just got numbers in here, so these could be student ID numbers or stock numbers or something like that. So we're going to see, does an item exist? That's what the search is trying to tell us. It either exists or it doesn't. So let's say we were looking for the number 23, which we, because we can see the whole list, can say, oh, it's not in there. Computer can't do that. It works one item at a time. So we start with the first item, and all we do, it's a very repeated process, and you can see that from the fact that I've got that little loop going on there on the little diagram. So we say, right, is the thing at position 0? That's where we're going to start. Is it what we're looking for? And we go, no. So what we do is say, let's move to the next position. Position 1. So we just increment. Nice simple process. Add 1. And we just look, again, and all we do is we keep saying, right, at the current position, whatever that is it the item we're looking for? If it isn't, move along. So in this case, we'll keep doing that until we try and access position 8, which doesn't exist. At that point, we say, we better stop. So that's one condition that makes us stop. We went off the end of the list. So, go to the end, doesn't exist. Fine, excellent. If we were looking for the number 19, we'd again, we can see it somewhere in the middle, but the computer can't be that clever. So it starts at position 0 and just goes, is it 43? No, move along. Is it 51? No, move along. Is it 12? No, move along. Is it 19? Oh, yeah, that's what we're looking for. So we can stop. And we can say, oh, we found it at position 3. So we've got two ways in which we can stop. And generally when you're searching, it is going to be, you either found it or you didn't find it. Okay? The real key things that you can also say about the linear search is the data can be in any order. There's nothing special about it. It can be all jumbled up. Linear search just doesn't care. Okay? It's the only search method that doesn't care. The one that we're about to look at, binary search, it does care because it'll break. It's fastest, and you sometimes get asked this, when will linear search beat all other searches? Well, if we were looking for the number 43, then we'd find it straight away. So we go, oh, first item, excellent. If it's the last item, then you've had to trawl through everything else. So linear search is nice and quick if you've only got a small number of items. Doesn't require any great processing. You're just adding one and doing an if. That's all you're doing. So it's quite a simple algorithm. Okay, it's the sort of thing that you might use yourself if you just had, I don't know, you were checking lottery numbers. And your lottery numbers aren't in order, so you say, all right, okay, let's go through and do that. So if you've got something that's not in order, all you can do is go one at a time. You can't use any fancy method. Okay? So simple to implement, fast if the list is short. Even faster, just going a little bit deeper, if your array, your list, is in the cache, it's going to be quicker. If you haven't got to go back to memory, you can remember the CPU, cache, all the often accessed items in the cache if we've got space. So if you can, as a programmer, think about that, organize your data so it will stay in the cache, then you can get a massive speed increase. And a lot of programmers spend a lot of time trying to engineer software, particularly in games, so that they can utilize the cache well. And there's loads of great articles on that. Okay, so